Hello students, today I'll discuss one numerical problem related to first law of thermodynamics. Here is the numerical. The numerical is when the system is taken from state 1 to state 2, which is given in the figure. This is the figure here. When the system is taken from state 1, these are the states given in this figure. There are 4 states, 1, 2, 3, 4. I'll discuss this later. When the system is taken from state 1 to state 2, which is given in the figure, along path 132, 90 kilojoule of heat flow into the system and the system does 35 kilojoule of work. So the conditions are, first condition is how much will the heat flow into the system along path 142 be if the work done is 12 kilojoule. Second condition, when the system returned from 2 to 1 along the curved path, the work done on the system is 24 kilojoule. Does the system absorb or liberate heat, and how much the heat is absorbed or liberated? Third condition is if the U1 equal to 0 and U4 equal to 45 kilojoule, find the heat absorbed in the processes AD and DB. So we have to solve this numerical. Let's just solve this numerical. Here is the PV diagram for particular system. This is the PV diagram for that particular system, and here there are 4 states, state 1, 2, 3, 4 in this system, which the system is following. And in numerical, the numerical is saying when the system is taken from state 1 to state 2, when the system is taken from state 1 to state 2 along the path 132, when the system is taken from state 1 to state 2 along the path 132, system is following path 132. So in this condition, the 90 kilojoule of heat flow into the system, and the system does 35 kilojoule of work. Here 90 kilojoule of heat flow into the system for that particular path 132. So what it is given, Q132 heat flow is given for path 132. It is 90 kilojoule and the system does 35 kilojoule of work. So the work W is also given for path 132. It is 35 kilojoule. These two things are given. So if we apply first law of thermodynamics, the first law of thermodynamics for this system, for this condition is 132 Q132 Q132 equal to U2 minus U1 plus W132. Q is the heat flow, W is the work done, and here U2 and U1 are representing the internal energy for the state 2 and state 1. For the end state, state 1 and state 2. U2 for the internal energy for state 2 and U1 the internal energy for state 1. We have the value of Q, we have the value of W. We can find out the value of U2 minus U1. So here U2 minus U1 equal to Q132, value of Q132 is 90 minus W132. So the value is 35. So the value of U2 minus U1 will be 55 kilojoule. This is the value of U2 minus U1. Now the first condition is how much will the heat flow into the system along the path along the path 142 if the work done is 12 kilojoule. If the work done is 12 kilojoule. So we have the first condition. We have the for this first condition we have the value of W. we have the value of W for path. Path is given, it is 1, 4, 2. Now the system is following the path 1, 4, 2. So for that we have the value of W. It is 12 kilojoule. Now we have to find out the value of heat flow for this particular path 1, 4, 2. Again, we will apply first law of thermodynamics. Q142 equal to U2 minus U1 plus W142. Now we have to find out this. We have the value of U2 minus U1. So we will put the value 55 plus W is 12. This value is 67 kilojoule. This is the value of heat flow for path 1, 4, 2. Now the second condition is, in second condition, when the system is returned from 2 to 1 along the curved path. Here it is given when the system is returned from path 2 to 1. So in that condition, the work done on the system is 24 kilojoule. Here the value of W is given. W from 2 to 1 is 24 kilojoule. But what it is given? It is work done on the system. So this will be negative. Work done on the system. That's why the value of W will be negative. Now, what we have to do? We have to find out what it is given here. Does the system absorb or liberate heat, and how much of heat is absorbed or liberated? So it means we have to find out the heat absorbed or liberated by the system. It means we have to find out Q2, Q21. So we will apply again here first law of thermodynamics. The first law of thermodynamics for this particular condition will be Q21 equal to U1 minus U2 plus W21. We have the value of W21. We have the value of U2 minus U1, but here the condition is U1 minus U2. Why it is? Because system is following the reverse path. It is not from 1 to 2. It is from 2 to 1. So here 1 is the final condition and 2 is the initial condition. So for this condition, the internal energy will be U1 minus U2. So we have to find out the value of Q21 here. We have the value of U2 minus U1, that is 55. Here, this is the value of U2 minus U1. So we will write here minus 55. And we have the value of W21, it's minus 24. So the total value will be minus 79 kilojoule. See, here there is a minus sign. It means the system will liberate 79 kilojoule of heat. The system liberates 79 kilojoule of heat. The third condition is, some values are given here. If U1 equal to 0 and U4 equal to 45 kilojoule. The value of U1 and U4 is given here. Now find the heat absorbed in the processes 1, 4 and 4, 2. We have to find out the value of heat absorbed for Q14 and Q42. We have to find out these two values here. Now for that we have the work done for process 1, 4, or if we write here the process 1, 4, the work done for process 1, 4, 2, it will be W14 work done for 4 plus work done for 2. So this will be equal to W14 and the value is given in the first condition, that is 12 kilojoule. The value is given here 12 kilojoule. Now if we apply first law of thermodynamics for path 4, so it will be Q14 equal to U4 minus U1 plus W14. We have to find out the value of Q14. We have the value of U4, that is 45, minus U1 is 0 plus W14 is 12. So the value of Q14 will be 57 kilojoule. We have the value of Q14. Now next we have to find out the value of Q42. This value we have to find out. So we will what we have here, we have the value of Q142. From first condition we will take the value of Q142. This is 67 kilojoule. So if we write Q142 like Q14 plus Q42, we can find out the value of Q42. We have the value of Q142 and Q14. So Q42 will be 67 minus 57. So it will be 10 kilojoule. So the value of Q42 will be 10 kilojoule. Thanks for watching the video and subscribe the channel for more lectures.